I didn't press pause. It's playing the whole time. Okay. Anyway, so guys, now we are really starting functions, and I want to just give you a very quick introduction to what we're going to do here. We're basically going to look at four types of function, and we're going to learn how to read the graph and be able to write down what the function is, and the other way around, give you a function and you'll be able to sketch it. So the first kind of function we're going to work with, which we're starting today, is linear function, straight line. Okay? The second one, which you looked quite a lot, okay? The second type is, what do we call these ones? Remember? Maybe you don't know the name actually, okay? They are called quadratic equation, and the graph itself is called a parabola. Okay? Right? So these one, you've worked with them, maybe not in graphs, but you did work with them in algebra. You'll see it, you will look very familiar. A new one, a completely new one that you haven't come across before, are things that look like this. Okay? Right? So they're weird stuff that goes up to infinity. We call them hyperbolas. Hyperbolas. Okay? Hyperbolas. Okay? So that's something new for us. And then the last one are going to be the graphs that look like this. They either look like this, or they look like that. Okay? Or they can even look some other one. I don't want to draw so much. These guys are very common these days. Okay? They're called exponential graphs. And why am I saying they're very common? Where do you see them? Exactly, alright? So in infectious diseases and stuff like that, okay, exponential curves. So it's very, very relevant for these days. Okay? So it will take us a while, okay, pretty much until the end of the term to cover all these. Right. But today we're going to look at graphs. Guys, I've got a linear graphs. Okay? I've got y equal half x, x, and 3x. And they're all related to one of those. So the first little kind of activity I want us to do, which one is this? This graph. Which one out of these three? Half x. Okay? I'll ask you in a minute why. This one? Y equal x. Well done, Phoebe. And the last one obviously has to be 3x. How do we know that? Gradient. Okay? So that number in front of x is really the gradient. The bigger the number, the more steep it is. So 3x changes much more rapidly. Right? It makes sense, okay? Because I'm just plotting x equal 1, x2, x3. If that number here that multiplies the x is large, it goes up a lot. If it's less than 1, it's not very steep. If it's exactly 1, it's a line that crosses at 45 degrees. Why 45 degrees? Because when x equal 1, y will be equal to? If I put x equal 1, what will y be equal to? 1. When x equal 2, y will be equal to? 2. Okay, so you can see it's 45 degrees. Okay? So this number in front of x is your gradient. Does that make sense? Okay. What about if I had y equal minus 2x? What would that look like? So it's going to be going down, and it's quite steep. Okay? So not as steep as that, but steeper than this. So maybe something like this, or maybe more steep. Okay? Okay? All right? Does that make sense? Cool. That's the first step. I'll just pause here. So what I've done now, I drew a graph, y equal half x. And you can see it's not as steep as y equal x. And I want to do a new one, okay? Y equal half x plus 2. How would that look different? Based on all we've done in trig lately, you should be able to know what that plus 2 do. What effect is going to have? It's a vertical shift. Okay? You see how it's related to the trig graph. So what do we have to do? We take the blue graph and we do, what do we do to it? Move it up up by how much? 2. Okay, by 2. So when it was 0 here, okay, because when I put 0 it will be 0, now it's going to be 2. Okay. When x was equal 1, this was half. Okay. Now y will be equal to, if I put x equal 1, y will be half. When in the red one, x will be equal to 2.5. Okay? So it's going to be basically a straight line parallel to that, but just shifted up. Okay? So what we can see here, that functions that have the same coefficient for x are parallel. Okay? If I wanted to work with, let's say, y equal half x minus 1, what would that look like? What do I need to do to the blue graph now? Shift it down, but it's still parallel, right? So it's going to be minus 1. Now it's going to cross the y axis at minus 1. Okay? But they're all parallel. All these are parallel because they have the same coefficient. Does that make sense? Okay. Now, yeah, I'll just pause it for a second. A bit long. Right, guys, we're carrying on. So, to really finish up, okay, I've written the general form of the linear function. It's always going to be y equal ax plus q. Now, a, we said, is your gradient, right? It's how steep it is. If it's positive, it's going up. If it's negative, going down. Q, we just know it's something to do with vertical shift, moving up or down. But I want to kind of nail to know exactly what is that q. And to do that, we'll do this exercise together. So we've got two of these functions, 2x minus 1 and minus x plus 2, and we need to plot on the graph. And let's try and remember how to do it. You know how to do it. I want to draw these functions, green and the red. I'll just pause. So the guys here is saying, okay, how are we going to do it? We just need to choose a bunch of values for x, substitute in find y, and then plot the points, and then draw a line. But we also realize that for linear graphs, it's going to be different for other graphs, but for linear graphs, we only really need 2 points. You can do 3 just to make sure, but you really only need 2 points because there's only one straight line between 2 points. Question, what 2 points are there? Are you going to put x equal 1 or 2 or 1 or 5? You probably want smaller x's, so it's not too complicated. Now, I know you learn of different ways, cover method, draw. To be honest, I'm not too bothered about it, but I think there are one method, I think it's called the dual method, which is important. That's to understand what the intercepts are. Okay? So an intercept is when the graph crosses one of these axes. Okay? So this is x and this is y. So the y-intercept is when it touches the y-axis, and the x-intercept is when it crosses the x-axis. And how are we going to find it? Okay? Well, the y-intercept, okay, what is the x when the graph crosses the y-axis? What is the x around here? Okay, when the graph crosses the y-axis, x is 0, isn't it? Everywhere along this axis, the x is 0. So to find the y-intercept, okay, we're going to put x0. Okay, that's the y-intercept. So let's have a look at it. We put x equals 0, 2 times 0 is 0, 0 minus 1. So the green graph is going to cross here.
And then use minus 1 and 2.
Okay. Yeah, it's just going to be 0 minus 1. There's going to be a point here, 0 minus 1. Now I need one more point for the graph. Okay? Now that point, I can use any point. I can put x equal 1. But what I want you to do, it's a important skill to learn it, to find out what's the x-intercept. What happens to the y when the graph crosses the x-axis? What is the y along this x-axis? What is the y value? It's 0. Okay? So when the graph crosses here, you can see the y will be 0. So I'm going to put, actually instead of putting x equal 1, I'm going to put the y equals 0. How are we going to find out the x? If I know the y is 0, how am I going to find the x? I'm going to find the x if I know what the y is. Substitute. Instead of y, I'll put 0. So I'll put 0 equal 2x minus 1, right? Yeah? What is the answer? X equal to, can you do it in 2 steps? No? 2x minus 1 equals 0. X equal to? Half. I move the 1 over there, divide by 2x equal half. So when y equals 0, x equal half. Okay? Here I didn't write it, but when x equals 0, y was equal minus 1. Okay? Does that make sense? Okay, now I've got 2 points. I'll draw that. X equals 0, y equals 0, and x equal half. So this is half, 0. Okay? So now I've got 2 points. Now, of course, you would tell me, and you will be absolutely right, this was quite difficult. This was easy. We straight away substitute 0, we get minus 1. But this was difficult to get. It would be much better if I just put x equal 1 and put 2 times 1 minus 1 gives you 1. That would be much easier to use that point, 1, 1. But this is an important way because you need to be able to calculate the intercept. It's important for you to be able to calculate the intercept of a graph. Really, our aim here is not to draw that graph. Everyone can do that. But the aim here was for you to be able to use that equation to find out the y-intercept and the x-intercept. And I'll repeat it again. To find the y-intercept, you substitute 0 instead of x. To find the x-intercept, you substitute 0 instead of the y. Then you find it. Does that make sense? On Monday, I'll get you to practice that. Let's do the same thing with the rate. Okay? So the rate, we're going to try and choose 2 points. Okay? We're going to find when x is 0, find out y, and when y is 0, find out what x. So when x is 0, what is y? 2. Okay? I just put minus 0, which obviously is 0, plus 2 is 2. So the y-intercept is 2. Okay? This is 2. Let's say this is 2. This is 1. This is 2. Okay? So that's my point here. 0, 2 is an intercept. Okay? Now I want to know when y is 0. That's my x-intercept. So I'm going to put 0 equal minus x plus 2. X equal? What is x equal to? 0 equal minus x plus 2. X must be equal to? Plus just 2. Okay? I'm adding x to both sides. So x equal to. Okay? In other words, it's going to cross over here. It's 2, 0. And then I can draw a line. And I've got the line. Okay? Now, I want you just to notice something. This video is super long. Okay? I want you just to notice something. Okay? Can you tell me now what is Q? Check out this here. I'm going to highlight these 2 functions. Okay? We know that the A is your gradient. That's the gradient. Okay? A is your gradient. Okay? You can see it's a positive gradient, so going up, it's quite steep. Negative gradient going 2. Okay? What was your y-intercept for the green graph? What is the y-intercept? Minus 1. What is the Q in the green graph? What is the y-intercept in the red one? And the Q is? In other words, what is the Q? Y-intercept. Okay? That's the y-intercept. Okay? That's the main thing that I want you to get from this lesson. Okay? Y equal ax plus q. The a is your gradient, the q is the y-intercept. That's why it's so important to calculate intercepts. Okay? Guys, sorry I've talked to you a lot today. Next lesson, I'll just practice through the questions. Okay? Bye. Cheers.